In the expression above, a is a constant. If the expression is equivalent to bx, where b is a constant, what is the value of b? The polynomial on the left must have the same coefficients as the polynomial on the right, which is just bx. But the polynomial on the left isn't in standard form, so it isn't obvious what the coefficients in front of the x terms are. Let's fix that. Multiplying out the left side, we get 4ax squared minus 4x plus 4ax minus 4 minus x squared plus 4. And now here's the key step. To get the polynomial into standard form, factor out the x squared from each term that contains one, and similarly with the x. So we get 4a minus 1 x squared plus 4a minus 4 x. Remember, equal polynomials have equal coefficients. Since there's no x squared term on the right, that means that the implied coefficient in front of this x squared term is 0. And so 4a minus 1 is equal to 0, and so a is 1/4. Equating the coefficients of the x terms now, we also have that 4a minus 4 is equal to b, so b is 4 times 1/4 minus 4, which is negative 3. The equation above is true for all x where a and b are constants. What is the value of ab? Equal polynomials have equal coefficients, but we can't compare them until we get the polynomial on the left into the same form as the polynomial on the right. So let's multiply out the left side. We get 5ax cubed minus abx squared plus 4ax plus 15x squared minus 3bx plus 12. And this is the part that loses people. We need to factor an x squared out of each term that contains one, and then do the same for the x terms. We then get 5ax cubed plus 15 minus abx squared plus 4a minus 3bx plus 12 on the left. And if you notice, we don't actually have to solve for a or b individually. We just need the value of a times b. So the coefficient on the x squared term will give that to us. 15 minus ab must be equal to negative 9, so that leaves us with ab is equal to 24. If ax plus 2 times bx plus 7 is equal to 15x squared plus cx plus 14 for all values of x, and a plus b is 8, what are the two possible values of c? This one is a bit spicier, but the beginning is similar to the last two. In order to equate the coefficients in front of the x and x squared terms, we first need to multiply out this left side and then regroup the polynomial in standard form. So we get abx squared plus 7ax plus 2bx plus 14. Factoring out the x gives us abx squared plus 7a plus 2bx plus 14. So it follows that ab is 15 and 7a plus 2b is equal to c. We also have from the question that a plus b is 8, which we can substitute into the first equation. That gives us a times 8 minus a is equal to 15, 8a minus a squared is equal to 15, and finally, a squared minus 8a plus 15 is 0, which can be factored to a minus 3 times a minus 5 equals 0. That means a can be 3 or 5, which makes the corresponding b values 5 and 3 respectively. In retrospect, most of you could have guessed 3 and 5 from a times b is equal to 15 and a plus b is equal to 8, but just in case you missed that, I wanted to give you a rigorous argument to solve for them. In any case, going back to this middle equation, c could be 7 times 3 plus 2 times 5, which is 31, or 7 times 5 plus 2 times 3, which is 41. In the equation above, a, b, c, and d are constants. If the equation has roots -1, -3, and 5, which of the following is a factor of ax cubed plus bx squared plus cx plus d? If -1 is a root, then the corresponding factor is x plus 1. If -3 is a root, then the corresponding factor is x plus 3. And if 5 is a root, then the corresponding factor is x minus 5. The only answer choice that offers us one of these is b. One of the factors of 2x cubed plus 42x squared plus 208x is x plus b, where b is a positive constant. What is the smallest possible value of b? Well, let's try to factor this thing. We can pull out a 2x from each term. That leaves us with 2x times x squared plus 21x plus 104. And now we just need to factor this quadratic. We need two numbers that add to 21 and multiply to 104. So let's think about the factor pairs of 104. 1 times 104 is 104, but those don't add to 21. 2 times 52 is 104, but those also don't add to 21. How about 4 and 26? Still no. Let's keep going. 8 and 13? Yes, those add to 21. So we have factors of x plus 8 and x plus 13. b is the smaller of these two positive constants, so it must be 8. My guess is that you didn't love that factoring process, so you'll be happy to know that Desmos would have been a lot faster. Notice that if we simply type this equation into Desmos, we end up with the roots -13 and -8, which means the polynomial has factors of x plus 13 and x plus 8. The danger here is that a lot of people will mistakenly say the answer is 13, since -13 is less than -8. So there's a moral to the story here. Desmos can speed up your work, but you'll still need to understand the underlying theory just like students did in the old days when Desmos wasn't an option. The graph of the function f is shown in the xy plane above. Which of the following functions could define f? Looking at the graph, we see that the function crosses the x-axis at -3, which means the function has a factor of x plus 3, and that root has odd multiplicity. The function touches the x-axis at -1, but doesn't cross it, which means the function has a factor of x plus 1, and that root has even multiplicity. The function also touches the x-axis at 2, but doesn't cross it, which means the function has a factor of x minus 2, and that root also has even multiplicity. On the SAT, I've only ever seen roots with multiplicity 1 and 2, so odd and even effectively just mean 1 and 2. Answer choice C satisfies our demands, so that's it. Which of the following could be the equation of the graph above? The function crosses the x-axis at -3, which means the function has a factor of x plus 3, and that root has odd multiplicity. The function touches the x-axis at 0 but doesn't cross it, which means the function has a factor of x, and that root has even multiplicity. And finally, the function crosses the x-axis at 2, which means the function has a factor of x minus 2, and that root has odd multiplicity. The only answer choice that fits is B. If you've enjoyed learning about polynomials, then you also want to check out my next video on function transformations.